Hello there, pre-calculus students. This is Mr. Kashi speaking. With this video, we're going to go through the lesson in 9.4, which is on sequences. If you get stuck or need some more help, you can refer to page 732 in your textbook, and it should go through some examples there that should help to supplement your notes. This is a little bit of a change from what we've been doing last couple of days in class. We've been doing statistics and probability, and now we're switching to sequences, and then we'll be studying series in the lesson after this. So this first slide, what we're going to talk about is just these sequences of numbers. Okay, so what are the similarities and differences of the following sequences? So if you take a look, you've obviously seen lists of numbers before, but they're got to have certain patterns here, and hopefully, I think you can see like, oh well, maybe this first one we keep going up by, we keep adding 5, and then here we keep multiplying by 2, and here we keep adding 1, but more importantly, we'll get into those specifics later, but really what we're looking for is this. These two keep going, and the first one does not. Okay, so this first one stops. And what we say is that we call that a finite sequence. Finite sequence is one that has an end. It actually stops at a certain number. These second two, they don't stop. They keep going on. ... They're going to go on forever. And that is what we call an infinite sequence. And today what we're going to talk about is the different types of finite and the different types of infinite sequences. And there's obviously many different types, and they can get very complicated, but we're just going to talk about the characteristics of different finite and infinite sequences. All right. One way to represent a sequence would be by using an explicit formula. Explicit formula means that we're given an equation. Okay, so it says find the first 6 terms of and the 100th term of the sequence a of k equals k squared minus 1. So this is the main part right here. Okay, and the first 6 terms. So here we're going to talk about when we have a1. Okay, well, and then that would be 1 squared minus 1. That would equal 0. 1 squared is 1, and we're taking it away. And then we say a of 2, so that just means that we're plugging 2 in for k. So here we have 2 squared, which is 4, minus 1, which is 3. And you keep going, so on and so forth. A of 3 just means we do 3 squared, which is 9, minus 1, so we get 8. A of 4, so we have 4 squared, which is 16, minus 1, that's 15. A of 5, that is obviously 5 squared, which is 25, minus 1, that's 24. And a of 6 squared, that's 36, minus 1, that's 35. And then it says find the 100th term. When we use the explicit formula, that's pretty easy because we're just finding a of 100. We plug 100 in. 100 squared, that would be 10,000, and minus 1, that's 9,999. Okay, so explicit formula, just like a lot of the equations that you've used in the past, we're just plugging it in. All right, and I would like you to do that for those 2 down there. So if you could pause the video, do those same directions, find the first 6 terms, and then find the 100th term. Pause the video and complete that on your own. All right, hopefully you took some time to practice those. Here they're using some different letters. Over on the left we have U and N, and on the right we have C and N. But so here we're just finding the first 6 terms. We go U of 1, which means that we just have 1 plus 1, but we're also plugging 1 in here at the bottom. 1 plus 1 on top, that would be 2 over 1. That would be just 2. U of 2, we're plugging 2 in, so that's 2 plus 1 over 2, and that would be 3 in the numerator and 2 in the denominator. U of 3, plugging 3 in, 3 plus 1 over 3. That would be 4/3. You can just leave it as improper fractions. That's not a big deal in this section. U of 4, plugging 4 in. So hopefully you can see that the numerator is always going to be 1 more than the denominator. If you keep going, 5 plus 1 over 5, you might not even have to write it out. U of 6, that just means that 6 is going to be in the numerator, and 7 is going to be in the numerator, and 6 is going to be in the denominator. And then finally, U of 100, that would be 100 plus 1 over 100, and that would just mean that that's 101 over 100. And we're going to talk about what type of explicit formula that is. There's different types of explicit formulas. We'll talk about that here in a little bit. And then for C of n, we have to the third. This is going to get a little bit, you'd think this would get a little bit out of hand, how high this is going to get. C of 1, well, we have 1 cubed minus 1, well, technically that's 0. 1 times 1 times 1, that would be 1, minus 1 is 0. C of 2, that would be 2 cubed, which is 8, minus 1, that is 7. Oh, sorry. We got to subtract 2. That's an n, not just minus. Subtract 2, that would be 6. Okay. C of 3, so 3 to the third minus 3. So 3 to the third would be 27. 27 minus 3, that would be 24. Then we have C to the fourth. That would be 4 cubed minus 4. Well, 4 cubed, that is 64, minus 4, that would be 60. Okay, C5, we have 5 cubed minus 5. 5 cubed is 125 minus 5, that would give us 120. And then finally, C6, that would be 6 cubed minus 6. 6 cubed is, I believe, 216 minus the 6. That should give us 210. All right. And then finally, if we had C of 100, that would be 100 cubed minus 100. And 100 cubed is 1 million. And so then minus the 100, we would get 999,900, just like that. So hopefully you can see how these, it's plugging in the number. Explicit formulas are pretty straightforward. We cover those first because you've had a lot of practice of equations like that in the past. Now what we're going to talk about is a different type of formula. It's called recursive formula. And what the recursive formula does is it just takes the one before it, and then it does something to that number. Okay, so it says find the first 6 terms, find the 100th term, defined recursively. So here they tell us what B1 is. Well, we need some place to start. So our first term is 3, and then what it says here is take the number before it. That's B of n minus 1. That's the number before, and add 2. So here, this is going to be 5. We just add 2 to it. The third term is going to be 7. The fourth term is going to be 9. The fifth term is going to be 11. And the sixth term is going to be 13. So when it comes to listing out the first 6 terms, recursive formula actually is a lot easier to follow. It just says, hey, take this number and then add 2 to it. Or you could be subtracting 3 or multiplying by 5 or whatever it is. First listing out the first 6 terms, recursive is much easier. What the hard part is finding that 100th term. So if we wanted to find B of 100, that gets tricky because we need to know what the 99th term is. And so what I like to do is I like to mix it up a little bit. We're gonna take our first term, and then we are going to take our what we're adding by and multiply it by our the terms that we are multiplying by. So we're taking our first term here. So we have, if we had b of 100, our first term in this would be 3. So we're going to bring the 3 down. And then what we're going to do is, to get to our 100th term, we are going to add 99 more times. Okay, that's the best way I can explain it. Is we have our first term here is 3. Okay, and then we're going to add 99 more times. And when we do that, now we actually have an equation that we can use, and that's 201. So this is obviously an example of recursive formula, and hopefully it's clear that listing out the first 6 terms, recursive formula is much easier, but finding the 100th term, the explicit formula is easier that way. So please go ahead, and I would like you to use those same directions, list the first 6 terms, and find the 100th term for this recursive formula. Go ahead and pause the video and take some time to do that right now. Alright, hopefully you've taken a little bit of time there. So hopefully you can see a of 1, would they already tell us our first term, and then we're taking the term before it and we're subtracting 4. So a of 1, that would be 8, and then we're just subtracting 4 each time. So this would be 4, a of 3 would actually be 0, then we go on to the negatives. A of 4, that would be negative 4, a of 5, that would be negative 8, and a of 6, that would be negative 12. Alright, but then we have this a of 100 that we need to find out. Okay, so I'm going to be taking a1, and then I'm going to subtract 4, and then this is going to be b to the n minus 1. So once again, we're doing it 100 times. A of 1 would be 8, and then we're going to subtract 4 99 more times. That's how many more times. If we wanted to find the 200th term, we would be subtracting 4 199 more times, because it's 1 less than the 200. So that's kind of the harder part for students to understand. But if we subtract 499 more times, we'd get negative 388. So those are 2 examples of the recursive formula, and before that we did explicit formula, and hopefully you understand listing out the first 6 terms is a little bit easier with recursive, and finding the 100th term would be a little bit easier with explicit.